guys, we made it to chapter 12, tangent lines. This is 12.1. In your notes, we kind of talked about things being tangent in that graphic organizer we did. It's when you have a circle, all right, and a line goes right by and touches it at exactly one place. All right, so this point, let's say it was point M would be the point of tangency. So let's read about theorem 12.1. If a line is tangent to a circle, then the line is perpendicular to the radius at that point of tangency. So if I were to go ahead and pencil in a radii here, basically what that's saying is where the radii and the point of tangency meet, it's perpendicular, right? It's a right angle. Here again, I went ahead and drew it for you. I went ahead and drew circle A, circle O. This line's going through them. Point P is the point of tangency, which means right there, our radii and this line, AB, would be perpendicular to each other at point P, that point of tangency. Okay, so let's look at this problem right here. Example, ML and MN are tangent to circle O. What is the value of X? So right here, this line, ML, and if I wanted to extend it a little, I could. And MN, and again, I want to extend it a little, I could. There's tangent to circle L. So right here and right here, they're tangent, right? Because here's a radii. What is the value of X? Well, what you need to think of is that if ML and MN are tangent, then angle L and angle N, these both equal 90 degrees, okay? And then I know that this angle right here, angle LON or angle O, is 117 degrees. So then what you need to think of is, look, this has four sides, one side, two side, three side, four sides, which means it has 360 degrees total. All right, a four-sided figure, 360 degrees. So you would take 360, subtract one of the 90s, subtract the other 90, and subtract 117, and that would give you 63 degrees. That is your answer, and all that could be left for the measure of angle. That means the X, or the measure of angle M, would be 63 degrees. So keep in mind, you guys, when it tells you that things are tangent, that there's 90-degree angles that are created with the radii. All right, the next one is theorem 12.2. If the line in a plane of a circle is perpendicular to a radius at its endpoint on the circle, then the line is tangent to a circle. So we're saying if a line that is perpendicular to the radii of a circle, then that line must be tangent to a circle. Well, how does that apply? Let's look for a second. Okay, we'll look right here, and well, what we're going to think of is, what's the radius of circle C? Okay, well, we're going to just assume that these two pieces, that this segment is tangent and it's perpendicular. Okay, so what I've created right here is a right triangle. A right triangle where I know some of the sides. So if I know some of the sides, I can use the Pythagorean Theorem. So, use the Pythagorean Theorem. What you're going to do is you're going to take this side, which would be your hypotenuse, x plus 8, and you're going to square it, right? You're going to take this side, x, and you're going to square it, and you're going to take this side, 12, and you're going to square it. So when I square 8x plus 8, I get x squared plus 6x plus 64 equals x squared plus 144. Well, I'm going to simplify and combine like terms. I would subtract the x squared and those would cancel out. And then I would subtract 64 and I would get 80. So I would be left with 16x equals 80. Right? And then I would divide by 16 and divide by 16. I would end up with x equals 5. So knowing that they're tangent and perpendicular, I was able to use the Pythagorean theorem and solve for my rate A, or x. This one's a little bit different. Is ML tangent to circle N at point L? So, here's my circle, N. All right, here's point L, and ML comes right through. We want to know if this is actually tangent, all right? If it is tangent, it has to be perpendicular. So that means I would have to use my Pythagorean theorem, and if it actually works for the Pythagorean theorem, then you know that this is 90 degrees, which means if it's 90 degrees, then it's tangent. So I would do 7 squared plus 24 squared equals 25 squared. Remember, it's each leg squared, so 7 plus 24 equals your hypotenuse squared. That's going to be 49 plus 576, and that's going to equal 625. Well, 49 plus 576 is 625, and 625 does equal 625. So yes, it's tangent because it's a right angle. The Pythagorean theorem proved that it was a right angle, and it was true. And that is it for tangent lines, guys. See you later.